Hey guys, so we're going to continue identifying some key features of graphs, but this time we're going to be looking at an infinite graph. The reason why this is considered an infinite graph is because we have arrows, meaning that the graph goes on forever. So this extends past what we see. So we're still going to answer the same questions, starting with whether or not this graph is a function. So remember, to be a function, every input must have exactly one output. And we can see if a graph is a function by performing the vertical line test. So I'm going to go right ahead and draw a vertical line on my graph. And I'm going to see how many times my vertical line intersects my graph. So my vertical line intersects my graph here, and my vertical line intersects my graph here. This is a problem, okay? Because that means if I go to this input, which is 1, 2, 3, 4, 5. So if I go to the input 5, my output could be 2, or my output could be -2. But every input should have exactly one output. This input has 2 outputs. So this fails the vertical line test. Okay, so this is not a function. Fails the vertical line test. All right. So now we're going to go ahead and determine the domain and range of the graph. So I'm just going to write some notes again. The domain goes from left to right. I want to look at my point that's the farthest to the left of the graph and my point that's the farthest to the right of the graph. And I like to do this by kind of boxing my graph in, okay? So I'm going to go the most to the left. This is the most left point of my graph. And then I'm going to go the most to the right. And this is looking like my most to the right point. But remember, we have arrows. So my most left point occurs right here at an x value of 0. I don't see any open circles, so I'm using a bracket. However, my most right point isn't technically here because I have arrows. So I could have extended this graph. I could have extended this graph. I could just keep going on and on forever. So I don't really have a point that's the most to the right. There's no end on the right. So my end is just going to be infinity. Okay? And since infinity doesn't have an exact end, I'm going to use a parentheses. I can't really include infinity because I don't know where infinity ends. Now my range, remember, we're going to use red this time, is going to be going from the bottom to the top. So once again, I'm going to kind of just bound this graph in. This looks to be the lowest. This looks to be the highest. But once again, I run into the same problem. There's arrows. So if I extended my graph, my lowest point would change. And same thing at the top. If I extended my graph, my highest point would change. So all I can use are infinities for my bounds. So my lowest point is negative infinity, and my highest point is positive infinity. Because I don't know where in the negative direction this graph ends. I don't know where in the positive direction this graph ends. Now let's look at our x-intercepts. So x-intercept is where the graph touches the x-axis. My graph touches the x-axis right here at 0, 0. My y-intercept, where the graph touches the y-axis, is going to be the same point actually, right? Because it touched my x-axis here. This graph touches my y-axis here. So it's also the point 0, 0. Okay. For this graph, I can't determine a maximum value because it goes on forever. There is no max. For this graph, I can't determine a minimum value because it goes on forever in the negative direction.